A very good evening. Today we are going to present case study 2 about telemetry and data aggregation for chapter 6. Let me introduce myself. My name is Danushini Naparpan Steven. My metric number is 16 DEF 21 F1072.
My name is Sivasankar Alaki Sivbala. My matrix number is 16 DEM 21 F1005.
My name is Bhavesh Magendran and my matrix number is 16DM21F1999.
My name is Aishwarya Desai and my metric number is 16DM21F1012.
My name is Sharan Analaki Loganathan. My matrix number is 16DM1068.
6.1 Data acquisition system used to measure and record signal. Signal originating from direct measurement of electrical quantities. Signal originating from transistor. Data acquisition systems are used in large and ever-increasing number of applications in variety of industries and scientific areas. Analog data. Transducer as an electrical signal. Signal transmission, amplifying or modify it. Visual display device, oscilloscope, panometer, graphic recording instrument, minor galvanometer recorder. Magnetic tape instrument. For the digital data, transducer used as temperature, pressure, and acceleration. Signal condition used as strain gauge gauge, balance, and power supply. Scanner or multiple signal converter used as amplified low-level voltage, analog to digital converter, auxiliary equipment, digital recorder. So like in below, we can see the element of digital data aggregation system.
The next subtopic is structure of telemetry system. Set of communication system used to collect data at a place that is remote or inconvenient and to relay the data to a point where the data may be evaluated. Used in testing of moving vehicles such as cars, aircraft, and missiles. The third is transmission of data for monitoring and control over long distance. The last one is a DC voltage or current convert to audio tones. Below is the block diagram of telemetry system. Next is the type of system. Landline telemetry system. Power lines, telephone lines, and electrical wires. Distance range from 50 meter to 1 kilometer. Application for labs, industrials, and more. Type is a current, voltage, and position. The second system is a radio frequency system. Radio ranged from 1 kilometer to 5 kilometer at 4 megahertz. For distance more than 50 kilometer, microwave link range 890 megahertz to 30 gigahertz are used. Repeaters are installed after every 30 to 60 kilometer for long distance transmission. Voltage telemetry system. The measured variable is transmitted in form of voltage. At the transmitting end, slide wire is connected in series with battery. Slide wire is further connected to Bourdon tube for pressure measurement. When pressure change, slider actuates the slider of potential meter. Thus, change in voltage is transmitted to reverse. Below is a circuit figure of circuit of voltage telemetry system.
Okay. Current telemetry system. Working is almost same as voltage telemetry system. When pressure changes, Bourdon tube moves sliding contact thereby value current change. This current passes through a pair of wires and measured by millimeters. That is the diagram of the circuit of the telemetry system. Okay, frequency of telemetry. No physical link between telemeter and transmitter and receiver. Link is established through radio links. Example, in spacecraft, rocket, and missile correction actions can be taken from stations with of RF links. In instrumentation, the output of transducer is considered as a modulating signal. That is the diagram of the frequency telemetry system, block diagram.
Function of multiplexing systems. Multiplexing is the process of simultaneously transmitting two or more individual signal over a single communication channel. Multiplexing has the effect of increasing the number of communication channels so that more information can be transmitted through it. And lastly, the concept of multiplexer is the multiple input signal which combine into a single composite signal that is transmitted over the communication medium. And here we have a diagram of the concept of multiplexing. On the left, we have the multiple input signal MUX, and on the right, the original input signals, the DMUX. Demi-multiplexer DMUX processes input signal by sorting out into the original individual signals. And there are two basic types of multiplexing: frequency division multiplexing, FDM, and time division multiplexing, TDM. FDM systems are used to deal with analog information, and TDM systems are used for digital information. And there are two more types of time division multiplexing and frequency division multiplexing, which are synchronous and asynchronous.
Frequency division multiplexing. Frequency division multiplexing is based on the idea that a number of signals can share the bandwidth of common communications channel. Second is the multiple signal to be transmitted over this channel are each used to modulate a separate carrier. Each carrier is on a different frequency. Third is modulated circuit. The carriers for each modulation FC are on different frequency. Lastly is the carrier frequencies are usually equally spaced. Each input signal is given a portion of bandwidth. Below is the diagram of the FDM transmitter and spectrum of an FDM signal.
Last one, the division multiplexing. In TDM, each signal can occupy the entire bandwidth of the channel. However, each signal is transmitted for only a brief period of time. Six signals are transmitted over a single channel. Each signal is allowed to use the channel to fixed period of time, one after another. Once all the signals have been transmitted, the cycle repeats again and again. TDM used with the both digital and analog signal to transmit multiple digital signals. The data to be transmitted is formatted into serial data word. That is the diagram, the basic TDM of for 6 channel only.
That's all from us, madam. Thank you.